Hello everybody, this is James. I am a computer science graduate turned teacher, and in this video we're going to look into A-Level Computer Science Chapter 22, Artificial Intelligence. And this is the chapter outlined. And let's start off with what is artificial intelligence. So in essence, it's how to make computer do things at which at the moment people are better. Like a self-driving car, chatbot, and these are the most recently artificial intelligence that is starting to change our life. And to study it theoretically, we need to understand how first graph like this can be used in AI. So before that, let us first learn the few terms for a graph. This circle here is what we call a node, and the straight line here represent edges, and then numbers above this edge is what we call an edge label. So a very simple problem to solve in artificial intelligence is, let's say from this diagram, which path is the shortest path from A to F? So from A to F. And we have shortest in terms of the least weight here. And they are using our human intelligence. This is what I came up with. We can go from A to F using the ADF path, which will be 80. The weight will be 80. ACF, 70. ABCF, 65. And ABEF, we're going to have 100. And by just looking at this slide, we can see that 65 is the shortest path. And that's what we can do while if you learn math before. But then we need to teach our our computers an algorithm to find the shortest path. So this is when Dijkstra algorithm comes in. It is an algorithm that helps you find the shortest path in a graph. So first of all, in this algorithm, we need to identify which node here is the source node. And then identify the source node, create an empty set called shortest path set, and another one called remaining set, and put all the nodes including S into it. So we have the source node and an empty set, and then all the sets that are inside this graph. And I'm going to start this algorithm from source A. And by using Dijkstra algorithm, the goal is that we can find out what's the shortest path from A to all the other nodes. And that's the start of this journey. And this is the algorithm. Don't worry, it contains a lot of words, but I will make it simple. Now, this algorithm says that while shortest path set does not contain all the nodes, alright, then this is what we'll do. We'll pick the node N from the remaining node set that has the lowest value. So by the way, we have another row here called distance from the node to the source. Because A is the source, the distance will automatically be 0. And B to F will find it throughout the algorithm. But for now, we will put A into our shortest path set, alright? And for each node in the remaining adjacent nodes set that is adjacent to N. So what is N now? N is equal to A. And the nodes that are adjacent to A will be B, C, and D. And then for each node, I'm going to calculate a new distance value by adding the value given by the label for the edge connecting the two nodes to the already stored value for N. So N is equal to A, okay? And A has a value of 0. So the new distance value from A to B will be 10. And previously, if you look at it, if this value is set less than the value currently stored, replace this stored value by the new one. Before we calculate, you can see that BCD has an infinity value. So no matter what value we calculate, it will be less than it. So it will be replacing this distance. So we got 10 for B, and 30 for C, and another 30 for D. And then part C, if a new value has been stored, enter the sequence of nodes used to obtain this value. How do I get 10 here? I basically travel from A to B. How do I get 30 here? Travel from A to C, A to D. So this is when the sequence of nodes is labeled in the table. Now, it's all done. While the shortest path set, it still doesn't contain all the nodes. So I'm going to add B into it. Pick the node that from the remaining node set that has the lowest value. So in this case, I'm picking B because it has the lowest value. And for each node in the remaining node set that is adjacent to N, so which is B here, B is adjacent to A, C, E. But we are not considering A because A is not in the remaining set. So I'm only considering C and E. So let's start off with C for each node. Calculate a new distant value by adding the value given by the label, which is B to C, 15, and adding it with the value of B. So I got 15 plus 10. So that's the value I calculated. And B, if this value is less than the value currently stored, replace this stored value. I calculated 25, and what is stored in C is 30. So according to this algorithm, I'm going to replace this. So 30 becomes 25. And because the new value has been stored, I will update to the path. Instead of A to C, the shortest path to C is actually A, B, and C. So hopefully now it is a lot clearer if you don't understand this previously. Next up, I'm going to pick for another node that is adjacent to B is E, all right? And then I'm going to calculate a new distant value. All right, from B to E, because E is infinity, I will calculate 10 plus 40. That's the distance from A to E, right? And then I'll put this inside my E. And then I will showcase the path A, B, E. Now, since B has no more adjacent nodes that is inside the remaining set, I'm going to pick another node. So next one, I will pick C because C has the shortest weight value. I'm going to go to C. And then for each node in the remaining set adjacent to C, C is only adjacent to A, B, and F. But because A and B are not in the remaining set, then we are only considering F. So calculate a new value. So we'll get C is 25 plus 40. That's why we got 65. And then I'll update the sequence of nodes in the route. So that's it for C. No more C. And we're going to look into D next because D has the shortest, lowest weight value. Pick the node, we pick D. And for each node that is adjacent to N, again, those that are adjacent to N is A and F, but we're only considering F. So we calculate a new distant value. D has 30, and the weight of it is 50. 30 plus 50 is 80, and it's not greater than 65. And this is why I do not update the value of F here, because it is not the shortest path from A to F. And last but not least, I have F. That's the last value. I have E. Add it to the shortest path set. E again only have one friends. So E has a value of 50, and the edge is also 50. 50 plus 50, 100. Not greater than 65. Sorry, not less than 65. I made a mistake here. And then, doom, I don't update anything. So F is the last set because it has no adjacent set that is not in the remaining set. This is why nothing is done. So this is the final record of the data. And this table, if you look at it, it gives you the shortest path possible from A to B to C to D to E to F. Alright, the example I use here is not a very big graph, but it will work the same way even if you have a very, very big graph. And that's the power of algorithm. You can scale it. Now, let's go into another algorithm that is an improvement version of the Dijkstra algorithm. Path finding and graph traversal algorithm that efficiently finds the shortest path between 2 points by combining the benefits of Dijkstra, all the benefits in Dijkstra, with a heuristic and winning with some smartness. Let me explain. Imagine we are solving this problem. What is the shortest path from A to J? From A all the way to J. And instead of just considering the weight of each edge, in A-star algorithm, it also uses a heuristic value. So look here, from nothing to a heuristic value. Of course, the way we calculate the heuristic value is beyond the scope of this algorithm. But one method that we can use potentially is the Euclidean distance, which is basically the distance between 2 points by using their coordinates. So that's just one of the heuristic. There are many more types, but we are not considering that. So this algorithm, let's start from A. This is a simplified version. I'm gonna consider the 2 adjacent paths. So from A, I can go to C, and I can also go to B. And then instead of only considering the weight, I will add the heuristic up. So go to C is 3 plus 6, I got 9. Go to B is 6 plus 8, which I have 14. And we'll pick the path that has the lowest value. Therefore, we'll go to node C. And from node C, we have two different paths, to D or to E. And if you add the value up, you know that E has the lowest value. We'll go to E. Starting from E, we can go to G or can go to F. F has the lowest value. We go to F. And only one way to J from F. So we go to J. So this is when the shortest path has been found. Of course, this is an overly simplified version. But then we are really not considering the heuristic part of it. The idea is just that you need to know A star algorithm uses heuristic to determine the shortest path. So that's A star algorithm. It is superior because it incorporates a heuristic that guides the search towards the goal, resulting in a more efficient exploration of path and often finding the shortest path more quickly. Now, that's how AI works theoretically. Now let's look into some application. One field of artificial intelligence is machine learning. As implied by the name, it involves development of algorithms that enable systems to learn from data, identify patterns, and make predictions. And we have three different subfields of machine learning: unsupervised learning, supervised learning, reinforcement learning. Now let's look into what are these. So unsupervised learning is a machine learning paradigm where algorithms are trained on unlabeled data. So you are feeding the machine a bunch of data, but you don't label them. I'll show you some example to show you what label data means, okay? But you don't label them. And the idea is that you create conceptual clusters and to automatically group and organize similar patterns or entities within data, enabling the algorithm to uncover inherent structures. So let me give you an example. This is Google News. Just think about it. There are tons of news on the web every single day. And it is quite tedious for Google employees to go into each news and label them as sports news, local news, Malaysia news, technology news. And therefore, we need an algorithm that when you feed them with a bunch of news, they can categorize these news using the algorithm. So this is what I screenshot on the Google News website. If you notice, unsupervised learning is also being used on YouTube. They categorize the videos in your homepage to let you know this bunch of videos is about F1, this bunch of videos is about football, etc. without the need to label each video manually. And this is one example of unsupervised learning. I learned this in university. K means clustering. Imagine these are all the data points. And from the data point, you can cluster them based on categories. And that is how Google and YouTube classifies videos and also news. And there are more examples, but that's beyond the scope of this algorithm. Just remember that in unsupervised learning, the data is unlabeled. The supervised learning, on the other hand, we have labeled data. It's a machine learning paradigm where algorithms are trained on labeled data to predict or classify new instances based on the correlation between input features and known output labels. Let me explain. One example of supervised learning is a spam email filter. Now, this involves training the machine, the algorithm, to identify whether an email is a spam email or not. And the way for them to learn it is to feed them with a bunch of spam email. We labeled this email as spam to tell the robots, the algorithm, that this is the characteristic of a spam email. We also labeled a few normal email and tell them that this is what we call normal email and feed them into the algorithm. And by doing this, algorithm knows how to classify emails into spam and non-spam. Of course, this approach involves identifying what are the most frequently appeared words in a spam email, like discount, bundle, etc. And another example of supervised learning is handwriting recognition. We let the algorithm see, oh, this is 0, this is digit 1, 7, 8, 9. And over time, the algorithm will be able to identify the nature, the characteristic of each digit. That's how handwriting recognition work. And another thing is expert system. It is also used in supervised learning. It's a computer program that utilizes knowledge and decision rules provided by human expert, akin to supervised learning, where the system is trained on labeled data with explicit guidance to make informed decisions and predictions in a specific domain, which means you are having an expert to come in and train the algorithm to do specific tasks. So one example is the AlphaGo chess computer program. They really hired the experts from the chess field to really train the computer to play game like a real chess player. Alright, the next field of machine learning, reinforcement learning, in which it's a machine learning paradigm in which an agent learns to make decisions by interacting with an algorithm, receiving feedback in the form of rewards or punishment, and adjusting its strategy to maximize cumulative reward. And one example I saw on YouTube, this is interesting. This is a game made by developers, and this is the agent. And the goal of this game is to not collide with any wall. So reinforcement learning involves letting this agent play the game like thousands and millions of times until they find the correct path. And you can search it up on YouTube, Unity Machine Learning Reinforcement Learning Demo. And that should give you a better idea. I can't show the video here because of copyright issue. Now, one method that is used in supervised learning in terms of how we predict data is linear regression. It's a statistical technique that models the relationship between variables, in this case sales and advertising. And this function will take in input and predicts what the output will be. So let's look into this graph here, sales and advertising. The more advertising budget you spend, the more sales you get. That's good. And using the data, we can draw a line of best fit. We learned this in in science. And this line of best fit will then be the function that helps us to predict data. All right. So, for example, using this line of best fit here, I can ask the question, well, if I were to spend 30,000 in advertising, what is the expected sales I can get? And that's when this line of best fit comes in. We use data to create the line of best fit. And once we have the model, we can use this model to predict data, to predict the output of new input data. And that's linear regression. And because it uses linear graph, we can also have polynomial regression. And that's when you can see the data follow a polynomial pattern, a quadratic graph. And then, yeah, it's an extension. It's a statistical method that extends linear regression. Now that's machine learning and some of the techniques they use. You will certainly learn more techniques when you join a computer science degree. Now let's look into the best part of artificial intelligence. For me, this is the most advanced AI technique, artificial neural network. So this is the neural network in our brain we learn in biology, and it allows us to make decisions based on inputs. So if I hear something, I would then respond, and that's how neural network works in the brain. And for artificial neural networks, it is inspired by the neural networks in the brain, by the way. It also takes in input, and based on these inputs, they do calculation and produce the output. So let me explain each node one by one. So these nodes represent artificial neurons here. They take in data. And a node can receive one or more weighted input, just like how we can take in multiple inputs in life. And then each node contains an activation function. And this is a mathematical operation applied to the weighted sum of input. Basically, they produce an output values based on the input values. And you will see how this is useful in a while. And it also introduces nonlinearity and determine the output of a node or neuron. So let me give you an example of how neural networks works. So an AI system that uses artificial neural network is the sentiment analysis. So based on text given, the algorithm can determine the sentiment of this message. Is it sad, happy, or neutral? So that's just an example. But the point is, the question you might be asking is, but how do they figure out, how do they determine the sentiment of this text based on the input message? And before we do that, the algorithm will go through this process called back propagation. It is a training algorithm for neural networks that adjusts the weight and bias by propagating the arrow backward. So what does it mean? Let me explain the few steps. So this is not an easy concept. So first you have convert each word in the input sentence to a numerical representation. As I mentioned, each node has an activation function, and it is a mathematical formula. Therefore, it will only take in number. So the method would be perhaps convert it to ASCII numbers. And after the number has been encoded, the number will be fed into the neural network. And the neural network can have one or more layers. And then they will pass the numerical inputs through the neural network to get a predicted sentiment analysis. So basically, we pass the number through this function. Then it will produce output. This output will be fed into the input of this node and eventually feed into the output node. Do note that there can be many, many intermediate layers. This is just a simplified example. And we are not done yet. Compare the predicted sentiment with the actual sentiment label. So if, let's say, I input a message, I'm happy, and then they feed in here, but then the output is, this is a sad message. Then the algorithm will know that they need to adjust the mathematical function in order for it to produce an output of, this is a positive sentiment. All right? That's why they say compare the predicted sentiment with the actual sentiment label, calculating the arrow. And then they will propagate the arrow backward through the network, adjusting weight and biases using the back propagation algorithm to minimize the error. And repeat until the model learns to make accurate sentiment predictions. When I'm learning this, I stumble upon, by the way, this is the algorithm. And then this is a video that I watch when I'm learning deep learning, which is artificial neural network. I think it explains better. I would attach the link in the description, video description. So just check it out. I think this is a really good video to explain how backpropagation work in artificial neural network. And so that's the end of this video. We have talked about the few algorithms in AI and also artificial neural network. Each subtopic here is actually a subject in university. So if you have any question, just let me know in the comment section and I'll be happy to help. I'll see you in the next video. Goodbye.